Hello, Physics Nation. My name is Nate Larmond, and I'm getting some emails about what is up with this e-learning. So it's the same old deal. Like you're going to do an experiment. This is an experiment, um, and most students are just like, "Bah, what do I need to hand in? Forget seeking the truth. What do you want out of me? What does a demonstration of understanding look like?" So I'm spelling it out in the objective right here. You're going to produce a table, a graph, a sample calculation, and a written analysis. All right. Tables you're probably good at. I can cut a video for the spreadsheet. Graphs you're probably good at. I can cut a video for that. This video is about the sample calculation. So this is the traditional notes that we usually take before the experiment. I think you've memorized the checklist for producing these sample calculations. So here's the checklist. You should click on these hyperlinks if you want. Here's the assignment. This is the checklist. If you click on this guy right here, you'll come to this document, and this is an amazing podcast. It's called The Hidden Brain, and it's all about how highly trained, highly competent professionals still benefit from using a checklist. So that was the sort of inspiration behind my checklist. And how many times have we, said, put your name and date on the top of the paper? State the question. What's the purpose? What are we trying to figure out here? Do we draw a diagram? Of course we draw a diagram. And we're going to, show the calculations and any algebraic manipulations we do. We're not going to get to the tables and graphs in this video. So all I'm trying to hit are these four. So here's my sample calculation for the lab. The lab is acceleration as a function of drop height. So drop height is our independent variable. We're going to mess with drop height. That's our x, or our input. We're going to manipulate this guy. And we're going to see the effect on acceleration. That's our y, or our dependent variable. And the purpose of the sample calculation is to show the methodology, that is, how you make the measurements and what you're going to do with the measurements. So this is the short version of a previous video I made, how to make a metric tape measure. I can throw that in the news feed too. You basically just make some strips along a piece of paper 4.3 centimeters wide, and then draw these horizontal lines on here 5 centimeters up, 10 centimeters up, 15, 20, 25, like that. And then when you cut this piece of paper into strips, you tape this 25 to this 0, and you tape this 50 to this 0, and you can make a really big, long metric tape measure. You also need a stopwatch. So hopefully you have a smartphone. If not, I made another little video on how to use a pendulum to set time. And it's 3, 2, 1, go. You drop it, you measure the fall distance, measure the fall time, and these are the two measurements. All right, how long it takes, how far it goes. This is the first calculation. Distance divided by time equals the average velocity, except its velocity is constantly increasing. All right, so you're going to double the average velocity to find the final velocity, or the impact velocity. That's the second calculation right here. And finally, you're going to find the rate of change of motion, or acceleration. So take the final velocity, subtract 0, there is no initial velocity, and divide by time, and you're going to get so many meters per second per second. So how fast is this thing getting faster as it falls? And how does that acceleration change as you drop it from a greater and greater and greater fall distance? So that's the sample calculation. I'm just going to sort of drag you through this process one step at a time. And we've done a lot of sample calculations, but I'm obviously not there to hold your hand. I'm going to try to digitally hold your hand through this process. Thanks for watching. See you in the next video.